This was a journal published in Journal of Applied Polymer Science in 2012. The correspondent author was a lecturer from Monash University, Malaysia, collaborated with academics from Monash University, Australia, University Putra Malaysia, and Malaysian Nuclear Agency. This journal can be found in the online database on ResearchGate and Wiley Online Library. In this research, sago pulp was isolated from sago waste to prepare carboxymetacellulose sago pulp. Hydrogel were prepared by forming cross-link with irradiation procedures. The gel content and the swelling of hydrogel in different pH media were determined. CMSP were prepared in different degrees of substitutions and concentrations, and various doses of radiation were used to cross-link. The research questions are basically to investigate the relationships between all the variables. The parameter and conditions to produce different degrees of substitution of CMSP were studied in the previous paper of the same author. In this case, collection of new data and synthesis of previous data were demonstrated. It was also integrated with previous studies. The research paper is logically organized, which the procedures and the flow of the whole experiment is understandable and easy to follow. The data were collected by simple weight measurement and analyzed with the computer tool, JAWSOL 95 and FTIR. Each part of the results undertake very well with clear discussion and graphs. The interpretations of results were effective in showing the relationship between the variables. There are some characteristics have to be fulfilled as a high-quality research. First, it is based on the work of others. The optimum condition to produce CMC was previously studied by the correspondent author and was similar to the other paper as shown with some modifications. The dose of irradiation used on the CMSP mixture was based on a study on radiation cross-linking of CMC. Second, the methods illustrated can be replicated as a basis to future research. The swelling behavior of the polymer is playing an important role in entrap and release of the content of hydrogels. This concept has been adapted in colon-targeted delivery medication and encapsulation of probiotics to increase their functionality. Third, the research is generalizable to other settings. For example, CMC can be produced from other plant materials such as durian rind, palm kernel cake, and sugarcane. Fourth, it is based on some logical rationale and tied to theory. The intention of using irradiation to produce hydrogel is to eliminate the need of adding other polymer or cross-linker. CMC, when exposed to high-energy irradiation, would undergo ionization and lead to the formation of radicals on the main chain of the anhydroglucose unit of cellulose. The radicals formed are responsible for intermolecular cross-linking. Therefore, pure hydrogels can be produced when the intermolecular networks are formed. It has the capability to swell and retain a significant amount of water within its porous structure. Fifth, it is doable. The research involved in using simple chemical, electron beam machine, and FTIR spectral analysis. The method illustrated is simple and the equipment required is popular in most of the laboratory. Next, the research generates new questions. The composition of natural biopolymers exhibits variations. The variation in the mechanical properties have not been completely characterized, and potential immunogenic properties of such materials may pose additional problems. This research also demonstrates the incremental value by providing a lot of useful information in producing hydrogel at its optimum condition. This journal has been cited in other journals related to 5-aminosalicylic acid colon-targeted drug delivery and in vitro release of antibiotics. Lastly, it has an apolitical activity that should be undertaken for the betterment of society. Natural biopolymers have extended advantages over synthetic polymers due to their low cost, great availability, and biodegradability. Natural modified biomaterial hydrogel are of great interest because of their wide applications.